Hello, this is Looking Forward for Physics 306 for Tuesday, the 21st of January, 2014. Today in class, we talked about what happens when we have a line of charge. And we realized that if we took that line of charge and broke up its charge into elements dq was equal to the charge density lambda times the length element dl and integrated along that length, that we could actually solve the problem. I'd like you to think about a separate problem now, though. What if instead of a line of charge, I had an area of charge, maybe a flat plane, something like this, and I wanted to know the electric field at some point P up here? Well, you'd say, well, that's not terribly difficult, Dr. Doty. All you need to do is take your area there, break it up into area elements, dA, like this one. Find the vector from that script r, from that area element up to the point P. And once you've done that, do the last final thing and write down the element of charge as a dq is equal to a surface density, sigma, times the area element, dA. Now you converted the charge integral to an area or to a spatial integral. Solve it up, you're good to go. As an engineer, for solving a problem, that's exactly right. But as a physicist, that answer should bother us. Why is it that this lambda dl and this sigma dA should bother us, and what's the solution to that? The second thing that I'd like you to think about appears to be, at first, to be a separate problem, and that is, consider a sphere. Boom, there's a sphere. Let's imagine now that I put 3 charges inside that sphere. I'll put a positive charge right here at the very center. I'll put another positive charge maybe halfway out to the right, and one more positive charge pretty much close to the edge. And I can label those 1, 2, and 3. What I'd like to know is, what is the flux from each of those charges? Are the fluxes the same? Are they different? Once you've answered that, what does that mean? What does that tell you? Now, in these two separate problems, why does our offense at dq equals lambda dl and dq equals sigma dA, what does it have to do with this flux question? And what does the answer to that have to tell us about the nature of electricity and magnetism and the way that we go about describing it? That's Looking Forward. I look forward to seeing you tomorrow in class.